Currently, I am working on 3 projects. First 2 projects are related to design and development of UAV system, or we can say it's a drone system for mining applications. We received funding for these 2 projects around 1.3 CR from the funding agency IHFC IIT Delhi. It is a TIS of IIT Delhi. And these 2 projects are collaborated with the University of California, Advanced Robotics Laboratory of University of California, with Professor Kia. So if we talk about a drone system, that is also known as a unmanned aerial vehicle, which is an aircraft without onboard human pilot, right? So it is remotely controlled by the human operator, or it can be programmed autonomously. So we are working on both sides. We are also controlling through human controller, and we are also developing drone system, autonomous drone system. So these drone system includes various components like RC, remote controller, transmitter, power distribution systems, propellers, motors, basically where we are using BLDC motors, brushless DC motors, and obviously frame. So there are different type of variety of drone systems like quadrotor, hexacopter, octocopter. It's depend on payload capacity. So in my case, in my case, we are working on a quadrotor which have 4 propellers, and here you can see in the picture, it is a systematic representation of quadrotor. For developing a drone system, first we develop a mathematical model. We all know that whenever we develop any kind of system, first we need a physical system. Then on the basis of that physical system, we need a mathematical model of that particular system. After that, we generate the mathematical equations from some engineering models like FAM or Lagrangian approach or classical approach. Then we generate the differential equations. After these differential equations, we can solve any kind of tool like MATLAB or any equation solver tool, so that we can find the exact dynamics of any physical dynamic system. So here you can see the quadrotor, systematic representation of quadrotor. Here, these are the arms. So these are the arms, right? And this is the motors, and these are the propellers, the propeller indicated with motors, right? So here F1, F2, and F3 and F4 are the thrust force, which having this quadrotor model. And here X, Y, Z are the linear directions. X, Y, Z are the linear directions. So here this is, we can say, it is a local coordinate system and it is a global coordinate system. So here in a theta, phi, and psi, theta is a pitch, and phi is a roll, and psi is a yaw motion. It is in rotational direction. These are the rotational direction. So here M1, the M1, M2, M3, M4 are the moments. So M1 and M3 are moving in the same direction, and M2 and M4 are the moving in other same directions, so that it can neutralize the effect and make it conductor stabilized. So this is the basic systematic representation of the quadrotor system. So this is the mathematical model of quadrotor, where in the last figure you can see the F or M. F are the thrust forces, and M is the moments. So F is a Kf equal to omega squared. So omega I square is a omega 1, omega 2, omega 3, or omega 4. So these are the angular velocity of the propeller. Kf is a thrust coefficient, and mi is equal to km into omega I square. Similarly, omega 1, omega 2, omega 3, omega 4 are the angular velocities, and km is a drag coefficient. So we form the equations here: translation motion for the translation motion and the rotational motion. These equations we form through the Lagrangian mechanical approach. So this is the kinematics. So we need to connect that global coordinate system with the local coordinate system. So we form this rotational matrix, and these are the dynamics. So these are the torques, roll, pitch, yaw. T, L here F1, F3 are the thrust forces of F1 propeller or F3 propeller, and L is the length of the R. Right? So similarly for the pitch and similarly for the yaw. So Tx, Ty, and Tz are the we can say the torque in roll, pitch, and yaw in X or Y and Z directions. So this is the basic mechanism of any UAV system. So here, this is the quad rotor dynamics. We are generating the motor dynamics, Fi and Mi from the motor dynamics, and provide to the quad rotor dynamics. And we generally preferred mixing matrix approach for this application. In the mixing matrix approach, you can see if suppose if any UAV system we need to move in a left direction or right direction or pitch or your roll. Simultaneously, we have to control all the speeds of the motors with propellers so that we can use the mixing matrix approach. So here, this diagram is based on a PD controller approach, PID or PD controller approach. So here we are using a PD control, proportional derivative control, and we are giving the reference directory to the X reference, Y reference, or Psi reference, or Z reference. Suppose we need to move in a circular direction, or we need to move in a helical direction. So all can be decided through these references, these X, Y, Z, Psi, Z references, and this can be provided through PD control system and given to the mixing matrix. Mixing matrix generate the omega desired, and that will give to the motor dynamics, and then motor dynamics generate the Fi or Mi, which will give to the quarter dynamics. After that, we will get the states. States are the X, Y, Z, Psi, theta, phi, or its derivatives, and we sense these states and again give to the feedback to the our controller so that it can generate the error signal, right? So this is the whole mechanism concept of any UAV system. So this is the omega desired, how we obtain this omega desired. Right? So first we show the circular trajectory. So for the circular trajectory, we use the X reference, Y reference, is a R cos omega t and R sin omega t. And altitude Z is decided, the altitude means height of the drone system. So it is a, yes. So Z is the altitude height
Continue,
of
sir. Continue with this.
UAV dynamic, UAV system. So here we are taking a R is the radius of that circle where that's UAV will move. R is the 3 meter we are taking here, and omega is the 0.1 radian per second. So these are the other parameters which we are taking. Here you can see when we conduct the simulation, this is the simulation based on PID controller. Here you can see the drone is moving in a circular path, in circular trajectory. So first we generate the reference trajectory, and after that this controller try to follow that UAV system to stick on that reference trajectory. So this is the major role of the control system of any dynamics. So after once we have completed this simulation, we develop the codes, right? We generate the codes through this model and in form of C or C++ and give to the our microprocessor. Microprocessor may be Arduino and it may be Raspberry Pi. In my case, we are using a Jetson Xavier system and deploy this code to the that microprocessor. So that microprocessor gives command to the drone system. So this is the whole concept. In another case study, we are using a PID with sliding mode controller, and here we are using a helical trajectory. So this green dot generate the reference trajectory, and this drone following this reference trajectory in a helical path, right? So similarly, we can use other kind of controller system for a UAV like clamping controller. We can use MPC model predictive control toolbox. We can use. So there are many controller which can be used for the UAV dynamics. So this is the field testing which we have done in our lab. So this is the mechanical ground of IIT Roorkee. So this is drone system that we have constructed in our lab, and we are also developing some more drone systems for different payload capacity. Currently, we have developed for the 6 kg payload capacity, and we are planning to construct 8 kg, 12 kg payload capacity so that we can properly integrate with the payload sensors, because the lidar weight is very high, around 6 kg, 7 kg, 8 kg. So we are trying to integrate lidar system with our drone system. That's why we are increasing the payload capacity of our drone systems. So here you can see, this is the drone movement. Here we are this is our lab members. So here we are checking the stability of the drone system. Landing part is very crucial. So we are testing landing, proper smooth landing. So in another project, as I said, I am currently working on 3 projects. So this is a third one project. And intelligent UAV for disaster imagery for hazards monitoring and vulnerability assessment in flood affected areas. Here we are working on a imaginary applications, and we got funding for this project around 57.4 lakhs. And funding agency is the IHFC, IIT Delhi. It is a TH of IIT Delhi. And we are collaborated this project with the University of Norfolk, Virginia, USA. And so in this project, we have collected the images of flood affected areas. We are targeting Delhi region through drone system and pass these images through the proposed methodology. So here I am showing some methodology part, and so that we can identify the exact height of flood and extent area of flood affected area, right? So here you can see the process cycle. So first we collect the images and pass through the processing of images, and done some training testing of model of data set through that CNN or our mask our CNN process, and uh, and then detect the object and image segmentation. Object detection is generally preferred YOLO algorithm. You look only once. And image segmentation parts, we categorize image in a like water is there or a vehicle is there or any house is there. So we have to segment the images and classify image as it is flooded or not. And then finally we predict the water height and extend the flooded area. So here you can see these are the object detection part. Here you can see we detect the objective. Here, suppose in this picture, you can see the cycle and the dog and the background part. So we have to detect this is a dog, this is a cycle. So we use the YOLO, you look only once. This is the we can say open CV platform. So here you can see it can detect when you pass this image on a YOLO mechanism or YOLO algorithm, you can find it is a dog, it is a cycle, and this is a background part. Similarly, for the segmentation part, we have to find out which is the water, which is the greenery, because we have to take the images from the drone from the top. So it is very typical to identify the each component. So we are using a image segmentation part here. So easily here in another picture, you can see water is showing in a sky blue color and it is in yellow color. So we can identify the object from the images. So in another image, you can see this is the vehicles passing through on a flooded road. So we have to identify which is a vehicle, which is a car, which is the persons are moving on a road. So it can easily detect the images if we pass through the yellow. Similarly, in this part, you can see we have to segment it. We segmented this image and identified this is a car and this water, right? So now this is our team. This is some random pictures of my lab where me and my team are working on a drone technology. And we also demonstrate our product, our first product on the TIH exhibition at IIT Delhi, conducted by DST. So these are the team members where we are working on a different kind of payload capacity drone system. Here you can see this is the 6 kg payload capacity drone. This is a 2 kg payload capacity. This one we are developing for a 8 kg or 9 kg payload capacity. So these are the some random pictures of my lab. Now come to the theme of the FDP Industry 5.0. So introduction to Industry 5.0. Industry 5.0, it is basically a latest evolution in the manufacturing industry that combines the power of advanced technology with the creativity of human being, and also represent the shift towards a more human-centric approach to manufacturing, where machines and we can say machines and human works together to achieve higher level of productivity efficiency and the quality. Industry 5.0 is based on the idea that advanced technologies such as artificial intelligence, the Internet of Things, and the automation can be used to enhance the human skills and creativity rather than replace them of this technology. Uh, this means that while machines and robots will continue to perform repetitive and routine tasks, human workers can also focus that require higher level skills such as problem solving or decision making, we can say, and the innovation technique. Uh, so overall, we can say Industry 5.2 is not just about the increasing and efficiency of the productivity, but also about creating a more sustainable and social responsible manufacturing industry by emphasizing to reduce the waste and optimize resources and minimize the environmental impact of their operations. So this is the evolution in industrial revolution. We had three industrial revolutions. Uh, most we are experiencing the fourth one. Currently, we are passing through the fourth one, industrial revolution, and fifth one is the future of industrial revolution. So here in the figure, these revolutions in a timeline you can see, there were 100 years between the first three revolutions. First revolution was in 1784. Second one is in 1870, and third one is in 1969. So it took around 40 years to reach to the fourth one from one third. So it is possible that to reach the fifth one will take less than 40 years. So we have to target that we can take at least less than 40 years to reach the fifth evolution of industry. So in a industry 1.2 begin in a 18th century with the advent of mechanized production, and it was started with a German company, and where water and steam power were used to power machinery in textile mills and other manufacturing facilities. This revolution transformed the way goods were produced and lead to the growth of urban centers. In industry 2.0, basically based on mass production, assembly line, and electrical energy, and it began in the late of 19th century. And the adoption of electricity enabled use for the more complex machinery and production process so that it can increase the efficiency and the productivity of the industry. Industry 3.2 basically for the automation, computer, electronics, so here you can just CNC, NC machines came in this industry 3.2. So this revolution led to the development of new manufacturing techniques such as computer-aided design, computer-aided manufacturing. It also led to growth of the service sector so that more jobs became automated, right? Machine jobs may be automated. So we can say in industry 3.0, we connected the control with the mechanical machines. And industry 4.2, which we are currently passing, it is based on integration of physical and digital system, creating a smart factory, we can say. And it includes IoT, big data analytics, and cloud computing, which enables manufacturers to uh, improve efficiency and reduce waste and optimize the resources. So we can say industry 5.0 represents the next phase in this revolution, and building the advance of industry 4.2 and placing a greater emphasis on the human element of manufacturing. So machine and humans work together to achieve greater efficiency, productivity, and creativity, so that it either could on their this is the so that it can made possible through the use of advanced technologies such as collaborative robots, or we can say cobotics, and augmented reality, virtual reality, real-time data analytics, and it also emphasizes sustainability and the social responsibility with a focus of optimize resources and reducing the wastage. So now there are some key features of Industry 5.0. First is a human-centric approach, so that human and the machines can work together to achieve greater efficiency and productivity and creativity, that so that it can either on their own. Industry 5.0 is basically based on machine and robots are not used as a tools only. It can also used by the humans, right? It can think like humans, so that humans are still critical to manufacturing process and their abilities and are valued, and it can enhance through the use of advanced technology. So suppose we can take an example, if a human worker might use augmented reality glasses to guide machinery through a complex assembly process, right? So it can work alongside a collaborated robot to perform a task that it requires the precision and the dexterity, right? So second is a technology integration. It can be characterized by the integration of advanced technologies such as artificial intelligence and the Internet of Things and automation into a manufacturing process, so that these technologies are used to improve the efficiency, reduce weight, and optimize the resources. So suppose, for example, we can say sensors and IoT technology can be used to monitor production in real time, which allowing for a rapid adjustment to be made to improve the efficiency and reduce the downtime of the machinery. And robotics and automation can also be used to perform the repetitive tasks more quickly and accurately, so that workers or we can say human workers, freeing them to focus on more creative, and it can able to do some more complex tasks. uh, Next is a collaborative robot. It can also be termed as a cobotics. It can be designed to work alongside human workers so that it can perform tasks that require a precision and dexterity. Unlike traditional robots, cobots are not confined to cages and can work safely alongside the human workers, right? And cobot also designed to be easy to program and reprogram, so that can be quickly adapted to changes in a manufacturing process. So this is the UAV system that we are working here. It is also a part of a collaborative robotic systems. So because we can also control the that UAV system through the manually, or we can also make the autonomous. In current scenario, there are a lot of applications which are based on a drone system, like some house building, 3D house building we are creating through the drone system. Some pupils are using a mapping mapping the areas of cities or the roads through the drone system. Some in agriculture, we are using majorly using a drone system for agriculture applications, for the spraying, like, and the measurement of the area we are performing through the UAV systems. Next is a customization and personalization. So it enables the greater customization, personalizer of product, allowing manufacturers to meet individual customer needs and preferences. This is made possible by the use of technology like such as 3D printing, which can make a customized products on as per the demand, and also allowing customers to customize the products which can manufacture can improve the customer satisfaction and loyalty, and it can also reduce the waste and improving the efficiency of the system. Next is a very important, it is a sustainability and social responsibility. So major we can say the whole that's industry 5.0 based on a sustainability and a cobotics which combines all these key features. So industry, it can, the sustainability and social responsibility, it basically strong, it encourages to optimize the resources and reduce the waste and minimize their environmental impact so that it can be achieved through the use of renewable energy like solar power, and it can also optimize of the production processes so that it can reduce the waste, and also encouraging the use of the eco-friendly material. In addition, environment sustainability emphasize social responsibility with manufacturers to ensure safe working conditions and fair treatment of workers throughout the supply chain. In real-time data analytics, it optimizes the manufacturing process and reduce the downtime. So it is possible by the use of sensors and like other IoT devices, which can be monitor production real time and send data to analytics platform for an analysis. By analyzing this data, we can manufacture, identify the inefficiency, or we can say bottlenecks in the production process, and so that it can adjust as per the efficiency, and also reduce the downtime, right? So next one is the flexibility. Flexibility, we can also add one more, flexibility and agility. So it can also, we can say, digitize the twin technology, which can simulate the production process and also manufacturers to quickly adjust the production in response to changes as per the demand. So overall, Industry 5.0, we can say it characterizes the integration of advanced technologies like human-centric approach to manufacturing, a focus on sustainability and social responsibility, and commitment to flexibility and agility. By emphasizing these features, manufacturing process can be improved and it can also efficient. So the next is the technologies which powering the industry 5.2. First is a cobots. We can see collaborative robots, augmented reality, real-time data analytics, additive manufacturing, autonomous vehicles, cloud computing, and the Internet of Things. So for the cobots, collaborative robots or cobots, it can be designed to work alongside the human workers and performing tasks like as that kind of perform tasks which are repetitive, dangerous, and physical demanding. Cobots are equipped with the sensors and advanced technologies that allows them to detect the presence of humans and adapt their movements accordingly, and also ensuring safe and efficient collaborations. For example, we can take BMW uses a cobots in its assembly lines to perform repetitive tasks like tightening bolts and attaching components. So cobot work alongside human workers, freeing them up to perform more complex tasks. So major companies like BMW, Mercedes, so they are using a cobotic system. They are also performing operations through the human, but they are attaching robots also, so that robot also working on the same platform where humans are working, right? So in the next part is the augmented reality. Augmented reality is like a digital information onto the real world, providing workers with real-time guidance and feedback. This can be especially useful in a complex manufacturing process where workers need to access detailed instructions or data. Suppose we are taking an example in a general engineers using the AR technology to provide workers with real-time guidance during engine assembly. So this technology, we can say, overlay the instructions and diagrams onto the engine component and make it easier for the workers to assemble the parts in a corrective way. So this is the basic purpose of the augmented reality, right? One is a virtual reality, one is a augmented reality. So this both kind of things are associated with the industry 5.2. Next is a real-time data analytics. Real-time data analytics to optimize the manufacturing process and make data-driven decisions. This requires the use of advanced data analytics tools like as machine learning algorithms, big data analytics, predictive analytics. So Bosch company uses a real-time data analytics to optimize its manufacturing processes. They using a real-time data analytics for the optimizing its manufacturing process. The company using a machine learning algorithm to predict when machines will require maintenance or not, and also reducing the downtime and increasing the productivity of the system or assembly line. Next is the additive manufacturing. Additive manufacturing, I think you're already aware about that. Is a 3D printing process. In this process, three-dimensional objects we can create by layering materials on top of each other. In my lab, one PhD person are working on this additive manufacturing, 3D printing. He developed the robotic system for creating a, you can say, creating a object like like small objects. He developed some bricks. He also developed some kind of small homemade objects. So it is a part of Industry 5.2. For example, Adidas using a 3D printing technology to create a customized shoes for its customer. Uh, uh, we can suppose we want to a different kind of shoes and we go there in the shop, right? And we find out the shoes designs. We are showing some number of designs and we have to choose only one. So आपने उसको just click किया and you find out the exact design, and then इसके बाद वो गया मशीन में और they generate as per your demand, right? So similarly, जैसे अभी suppose we are going for purchasing a paint for our house, right? So वहां पर आपको मशीन होती है and you have to choose the color, and they can mix as per your demand. They can mix the color as per your demand. So this is a kind of this technology. We can make this product or any kind of our requirement as per our wishes. So next part is the autonomous vehicles. Autonomous vehicles such as self-driving cars and drones, which increasing the important in manufacturing logistics. These vehicles can operate without human intervention, allowing manufacturers to improve efficiency and reduce cost. Like Amazon are using this technology, and they uses a drones to deliver a package to its customers, and it can operate without human intervention, and also delivery packages direct to customers as their doorsteps. So there are various autonomous vehicles developing this time in our world. I have seen Tesla car in US. It is a self-driving car. They are using a multiple sensors. They are using this kind of technologies that we are using, like CNN. They are using for detecting the object detections, for object following. They are using some CNN technologies. Uh, Mass car CNN they are using for path planning, and some sensors they are using lidar sensor, Velodyne lidar sensors they are using to mapping the area. so that we can map the objects, what kind of objects are moving along the vehicle. So these kind of systems currently developing. And next is the IoT, cloud computing. Cloud computing enables the manufacturer to store and access a large amount of data and applications over the internet, and it allows them to scale their operations and access advanced analytical tools without having to invest expensive hardware and software. So we take an example, Siemens using a cloud computing to monitor and analyze data from its wind turbines. So the company collect data on the turbines and perform and send it to the cloud computing for analysis. So this enables Siemens to identify issues and optimize the turbines performance in a real time. So there are various advantages of Industry 5.2. So first, improved efficiency and productivity. These advanced technologies like AI, IoT, real-time data analytics to optimize the manufacturing processes and also reducing waste and increasing productivity. For example, if a predictive maintenance using data from sensor to anticipate the equipment failures and schedule maintenance before breakdown occurs, so that it can reduce the downtime and also improve the equipment efficiency. And in greater customization and flexibility, it can it can customize projects as per scale. For example, Adidas using additive manufacturing to produce customized 3D printed midsoles for their future craft 4D shoes. So this allows Adidas to meet the changing demands of customers and market, so that they can improve their competitiveness in the market. Next, the improved worker safety and well-being. It related to the that we are introducing a cobotic system or collaborative robot system, which can perform the task with the human. So they are performing like a repeated task, some dangerous task, or physical demanding task. So this reduce the risk of injury and improve the well-being of the workers. For example, if you are taking a BMW case, BMW using a cobots to assist with the installation of vehicle seats, which reduce the risk of back injuries of workers, because workers always fix the seats so that it can move repetitively. So it can reduce the repetitive injury problem of the workers. Industry 5.2 also enables the manufacturer to use the real-time data analytics to monitor and control manufacturing process, ensuring high quality products. For example, Rolls-Royce using the real-time data analytics to monitor the performance of the aircraft engines and identify their potential issues before they become critical. So it can also improve the quality of the object which they are producing. So it can also reduce the environmental impact. Uh, for example, additive manufacturing reduce the amount of material used in production. So while real-time data analytics, it can identify the areas where energy usage can be optimized. So Tesla Gigafactory in Nevada is a prime example of Industry 5.2, which using sustainable energy sources and advanced manufacturing techniques to produce electrical vehicles. Next is the improved supply chain management. So Industry 5.2 also enables manufacturers to use real-time data analytics to monitor and optimize their supply chains, improving efficiency and reducing cost. For example, Walmart in US uses a real-time data analytics to optimize its supply chain and reduce the waste. This allows manufacturers to respond more quickly to changing market demands and also disruptions like last pandemic, like COVID-19 pandemics. So overall, we can say Industry 5.0 offers many advantages over traditional manufacturing methods, improving efficiency, quality, sustainability, while reducing cost and improving worker safety, while leveraging advanced technology and real-time data analytics so that manufacturer can perform their operations, their competitiveness in a increasing digital world. So there are various challenges in Industry 5.2. First is a high investment cost. So the implementation of high industry 5.0 requires a significant investment in advanced technologies and infrastructure. For example, a company may need to invest in AI-powered robots, real-time data analytics, and IoT-enabled sensors to fully realize the benefits of Industry 5.0. This can be barrier for a small and for medium-sized enterprises that may not have the financial resources to make the necessary investment. So this is the big limitation of Industry 5.0. For example, if you are implementing Industry 5.0 in a factory, the setting may require a retrofitting of existing equipment or purchasing new equipment with the necessary sensors and AI capabilities. Suppose in my case, and we are developing drones, so if we are increasing the payload sensors on our drones, so each sensors around 2 to 3 lakhs. If suppose we are adding a lidar sensor in our drone system, so the cost of lidar sensors around 4 to 8 lakhs. So one drone system, the whole cost of drone system is around 21 to 22 lakhs. So it is quite high, right? Small funding agents like small labs, or we can say small industries, can't purchase this kind of equipments because one drone system is not sufficient for the mass production. It required around 10 to 15 drone systems. So it requires high cost. Some big companies like Amazon, right? BMW, these kind of companies can purchase this kind of equipment. So it also required a high skilled labors. So it required high skilled workforce that can design, operate, and maintain a complex system. So this creates a skills gap where there are not enough workers with the necessary skills to meet the demand. So let's take an example. Engineers with expertise in AI and data analytics are in high demand in manufacturing industries. Companies need to invest in training, education programs to develop a workforce that is ready for Industry 5.0. So next challenge is the data security and privacy concerns. So it relies heavily on real-time data analytics, which creates concern around the data security and privacy, which company needs to ensure that their data is protected from cyber threats, and they comply with the regulation around the data privacy. For example, if suppose any company using a IoT sensors to collect data on its manufacturing process, it needs to ensure that the data is encrypted or secured against the cyber attacks. So in addition, if your company needs to comply with regulations such as general data protection regulations, so that it can ensure that the data is collected and processed in a lawful and ethical manner. Next is the interoperability and standardization. It requires different systems and technologies to work together seamlessly, which can be challenged due to differences in technology standards and protocols, which requires industry-wide collaboration and standardization efforts to ensure that the system can interpolate. For example, a company that uses a proprietary data analytics tools, which may need to ensure that it can interpolate with the other system, or other system used by the supplier and customers. So it requires collaboration with other companies in the supply chain to agree on standards and protocols for the data exchange. Another challenge is ethical and social considerations, like it like impact on employment and need to ensure that new technology are used to ethically and responsibly. Right, company needs to consider these factors when implementing industry 5.2. This is the main factor for highly popularized countries. So a company that implements AI powered robots to replace human workers, which may need to provide training and support to help the affected workers transition to new roles, right? So company needs to ensure that their use of AI and data analytics does not result in biased or discriminatory outcomes. कि आपने एक वर्कर को तो ट्रेनिंग दे दी और दूसरे वर्कर को आप ट्रेनिंग नहीं दे पा रहे हो, so this discriminatory outcomes will come, and that they are using these technologies to create social and environmental benefits as well as economic benefits. So I'm here taking some case studies which implement Industry 5.0. Siemens is an industry which implemented 5.0. It is we all know that Siemens is a multinational technology company that has implemented 5.0 principles in its manufacturing process. The company uses a real-time data analytics and AI-powered robots to optimize its manufacturing process, which results in increasing efficiency and reduce the downtime of the product. So Siemens using an AI-powered robotic system to automate the assembly of gas turbines, and the system enables with the computer vision techniques to identify the parts and using a machine learning algorithms so that it can optimize the assembly process. This resulted in increased efficiency and also improved the product quality. BMW also implemented Industry 5.0 in its manufacturing process. They used IoT sensors and AI algorithms to create a visual replica of the manufacturing process. This allows BMW to identify the potential issues and optimize this process before they occur, and also results in increased efficiency and reduced cost. So BMW uses this technique in a digital twin system to optimize its painting process. For the system analyze data from IoT sensors to determine the optimal paint thickness and the curing time, and also improve the product quality. ABB robotics system also implemented Industry 5.0 principle in its manufacturing process. ABB uses a collaborative robotic system that can work alongside human workers to increase the efficiency and reduce the downtime. They use the AI algorithm though to learn from human workers and optimize its performance over time. ABB uses the cobotic system to automate the assembly lines of the electronic components, and they also use the machine learning algorithm to optimize the assembly process and also improve the product quality. Rolls-Royce uses IoT sensors to collect the data on its engine during operations. The data is then used to optimize the maintenance schedules and reduce downtime, resulting in increased efficiency and reduce the cost. Bosch is a leading technology company that implemented Industry 5.2 in its manufacturing process. They're using a vision-guided robotic system to automate the assembly for its automotive products. The system uses a computer vision to identify the parts and uses a machine learning algorithm to optimize their assembly process. They also increase the efficiency and improve product quality by the using of this computer vision or machine learning algorithm. So these are the companies which implemented successfully Industry 5.0 in their manufacturing processes. So this is some videos I have downloaded from the social media. This is the video of evolution of robots. So first robots was introduced in 77 to 1000 BC, and first human robots was introduced in 1495. So these are the other robotic system which generated in us. So these are the some other videos. This is the motorbike. It can convert it into a drone system. It can fly also. So these kind of technologies where researchers are continuously working. This is the super advanced robotic dog. However, first dog was generated by Boston Dynamics. So a smart dog. It's another robotic system. This is a bipedal robotic system. So I want to discuss this part, but I think time is not allowing me because I have to attend one another meeting. Sandeep sir.
Yes, sir. Uh, Thank you, sir. On the behalf of IIMT University, I am Sandeep Karnwal, SCT, School of Engineering Technology. It was a wonderful lecture, sir. And Industry 5.0, we have seen some robotics pictures you have shown in your PPT. And special thanks to our patron ma'am, Professor Dr. Deepa Sharma, Vice Chancellor, IIMT University, and our convener, Professor Dr. Yatendra Chaturvedi, as Dean SCT, and organizing committee. Special thanks to our coordinator, Dr. Kuldeep and Dr. Pankaj. Thank you very much, sir, to give us such a wonderful lecture on Industry 5.0. Thank you very much. And over to Dr. Yatendra, sir. Please, sir, give him some. Hello, Kuldeep, sir.
गुड मॉर्निंग सर. एक्चुअली सर
Good morning, sir.
हाँ हाँ सर, डीन सर अभी अवेलेबल
Okay,
नहीं है,
Kuldeep sir,
वो कुछ
say
इशू चल
something.
रहा है जो उनका. हाँ ओके.
Okay, Pankaj, sir.
Yes sir. Thank you so much, Dr. Ashish sir. Sir, it was a wonderful lecture. It's
Thank you so
our
much, sir.
privilege to listen this lecture, sir. on the behalf of full IIMT University, I want to thank you, sir. The way you described all the insights about the industrial automation and robotics was really great. I hope that everyone, all the participants have enjoyed this lecture and find a way to move forward in this particular area. I want to know if anyone has any query, then they may ask.
Yeah, definitely. If anyone have any query, please ask me, or you can also mail me. You can take my mail from Sandeep sir. You
Yeah,
can
sure,
call
sir.
me anytime. If anyone interested to work in a robotics or this drone technology, because we have a lot of fundings and we are also working with some collaborative US universities. So if you anyone interested to work in this particular areas, they are welcome and they can contact me directly on over phone or mail. Yeah, any query related to
Yeah, Kuldeep
So
sir.
if anyone has any query, they may ask directly to sir.
Yeah, Kuldeep sir.
Yes,
I am
sir.
audible, sir.
Yes,
Yes,
sir.
sir, you are audible, sir. Please go ahead.
Okay. Okay. A very good morning to Professor Ajay. Hello, I
Ashish
am
Gupta,
audible.
sir. Yes, sir.
Sir, I am audible.
Vipin, sir, you are audible, sir. Yes,
Yes,
sir,
yes,
are
you are
yeah,
audible.
audible,
Vipin
Please
sir.
go
sir,
ahead.
you are
Sir, a
audible.
very good morning to Dr. Ashish Gupta, sir, for
Good morning,
delivering us
sir.
such a wonderful lecture, which is based on the Industry 5.0. Sir, I have a one doubt in my mind.
Yeah, sure,
If I
sir.
am
Please
talking
share.
about the Industry 4.0,
Yeah,
it is basically an integration of Internet of Things, machine learning, IoTs. But if I am talking about the Industry 5.0, it also involves the Internet of Things, machine learning, and additive manufacturing. Sir, can you answer can you give a difference in a one single sentence? What is the basic difference between Industry 4.0 and Industry 5.0?
industry as I understand about the industry 5.0 and 4.0 and the industry 5.0. In a 4.0, we are deploying these IoT and AI 2D systems. And industry 5.0, we are also providing some human interventions. Like if suppose we are doing some task, right? So before in this industry 4.0, we are giving the robotic system. We are giving this task to the robotic system through only giving this task to the robotic system. But industry 5.0, human also working on the same task and robotics is also involved in this particular task. So human and robotic interactions we are working in, we are focusing on industry 5.0 as I understood.
Okay, thank you, sir. Thank you. Thank you for your nice answer. Thank you, sir.
Okay,
Thank you very much, Vipinji. If anyone else is still having some query, they may ask to sir. Sir, I'm not finding that anyone has any query right now. Again, Ashish sir, I would like to say that your wonderful way of answering the problems or explaining the things is really great, sir. It was very interesting lecture. We enjoyed a lot, and we would like to have more lectures in future too.
Yeah, definitely, no problem. Thank you,
Thank
sir.
you so
Thanks
much,
for
sir.
inviting me.
Thank you, sir. With this, I hand over this session again to Sandeep Kanwalji to conclude.
Thank you, sir. Now, Ashish, sir, please, we are very thankful to you. You have
Yeah,
you
Sandeep
are
sir, can I
with us,
can
and
I
now
leave?
you can leave the.
Yeah, thank you so much, everyone. Thank
Sir, yeah, you
you,
can leave, sir.
management.
Okay.
Thank you, organizing committee. If you have any query,
Thank you,
still
sir.
you can mail me. You can call me anytime. Okay. Thank you. Thank you
Sure,
so
sir.
much.
Thank you so much, sir.
I'll share your mail, sir, in the group, sir. Thank you, sir. Now we can bind up for this session. Right now, we will be afternoon session after 1 p.m. Only 2 p.m. and we
1:30,
can
sir.
join again at 2 p.m. after lunch. 1:30. Okay, we can join
Sir,
at
at
1:30.
1:30 p.m.
So please, everybody should be at 1:30 p.m. sir. Okay. Everyone should be there on time. Thank you very much, and you can leave the session right now. Thank you, sir.